Hey guys, it's Miss Johnson here, and I'm here to bring you your video for our notes on solving systems of equations that have three variables. Three variables today. So we're going to start off just with a little warm-up on writing and solving a system with only two variables, just to kind of get our brains in gear here. Up at the top of your page, it says Krista and Arthur both need pens and blank CDs. The equation that represents Krista's purchases is y equals 27 minus 3x. The equation that represents Arthur's purchases is y equals 17 minus x. If x represents the price of the pens and y represents the price of the CDs, what are the prices of the pens and CDs? So couple things here. We need to look at both equations, y equals 27 minus 3x and y equals 17 minus x. And we need to figure out where those two things are going to be equal. Now, we can use substitution here pretty easily because we have both of these equations solved for y. So I can take the 17 minus x and plug it in for y there. So I'd have 17 minus x equals 27 minus 3x. And that's going to give me my x variable alone. So if I solve that, I want to add 3x to both sides. So I have 17 plus 2x equals 27. And then I'm going to subtract the 17, 2x equals 10, and divide by 2. So I end up with x equals 5. Okay, so there's one of the equations. Then I can take that and I can plug it back into either one of the originals and I'll get the y value. So I have y is equal to 17 minus 5. That's y is equal to 12. Now, half the battle is just figuring out what these two solutions represent. So up in the original question, it told us that x was the price of pens and y was the price of CDs. So that means pens are $5 and CDs are 12 bucks. All right. So that's a system of two equations with only two variables. Now what happens when we have systems of three equations? We got a whole different ball game here. If we've got three variables, that means we need to have three equations. That's the only way that we can solve a system with three variables. So let's look at our next example. In the next example, it says that at the 2004 Summer Olympics in Athens, Greece and the United States won 103 medals. They won six more medals, gold medals, or in Athens, Greece. The United States won 103 medals. They won six more gold medals than bronze, 10 more silver medals than bronze. Write a system of three linear equations that could be used to determine how many of each type of medal was won. So they give us our variables here, and that's really important that we name our variables. We're going to say G is gold, S is silver, and B is bronze. And we need to come up with three equations so that we can solve this. So the first equation is pretty easy. If you think that they won 100, or if you know that they won 103 medals total, that means you can add the three variables together. You'd have G plus S plus B is equal to 103. Okay, because all medals together, they won 103 total. Then the other two, they won six more gold than bronze. Six more gold than bronze. So that means that the gold medals were bronze medals plus 6. And they also won 10 more silver than bronze, which means that the silver medals were bronze plus 10. Okay, so now here's our system of three equations. We've got three variables, three equations. Now, if we wanted to try and solve this for all three of them, we need to see if there's a way that we can eliminate two of the variables from any one equation. Well, if I look at the second equation, I have gold medals in terms of bronze. So I could plug this whole thing in for G. And in the bottom equation, I have silver medals in terms of bronze, which means I could plug this whole thing in for S. So I could use that top equation, plug that one in for S, plug that one in for gold, and keep the bronze, and then I'd have all bronze medals in one equation. So that's what we're trying to accomplish. We're trying to get one equation that's in terms of only one variable. So if I do that, if I plug all those in, I'm going to have bronze plus 6 That's in place of my G. I'm going to have bronze plus 10. That's in place of the S. Then I have the bronze that was already there, and that altogether is going to equal 103. Now, if I go through and solve this, bronze plus bronze plus bronze is 3B, and 6 and 10 is 16. So then I want to subtract the 16, and I end up with 3B is equal to 87. And then I divide by 3, and I end up with B is equal to 29. So that tells me the number of bronze medals. So that's a good start because now I know one. Now what I can do with that is I can take the bronze medals and I can plug it back into both of these equations. So if I do that for the gold, I'd have gold equals the bronze 29 plus 6, which means gold is equal to 35. I can also do that for the silver, take that and plug it into the silver equation. Silver is equal to 29 plus 10, which means silver is equal to 39. So all together, I know that there were 35 gold medals, there were 39 silver medals, and there were 29 bronze medals. Okay, so I've solved that system of three equations there. I've got three variables, three equations. I need to try and get down to one equation and then see if I can solve that for the variable that remains. All right, so let's go ahead and take a look at our next example. Actually, you know what? We're going to stop our video over there for today. Short video. We'll do these examples in class together. And thanks for watching. Don't forget to go back to Schoology and take your quiz.